Hello, everyone. Well, I think I was already introduced, but I'll do a quick introduction again. I'm Egor Zakharov. I work as an engineer in Samsung AI Center in Moscow, and I'm a PhD student at Skolkovo Institute of Science Technology. Today, I'd like to tell you about the work that we did in our company recently, which got a lot of people's attention. So this work is about realistic neural avatars. And, well, what is an avatar? Avatar is some sort of virtual representation of yourself that you can recognize yourself in. And what do we need avatars for? So the problem that we're tackling here is the problem of telepresence. Telepresence is the way we can communicate over long distances. So not just being in a room, but for example, using some sort of remote communication system. And the first system that allowed us to communicate over the distances were actually books, written texts. And you can't overstate the disruption that brought to the history of humanity. So some say that history started when it started being written. And the next big disruption that came is the ability to communicate with text in real time. So this invention also changed the world. But when we try to think about the inventions that came after that. Well, before that, we had the modality of the text, which conveys most of the meaning of our conversation. When we introduced the modality of audio, so the sound, well, these inventions were not so disruptive. Cell phone was disruptive just because it gave us ability to communicate anywhere. But even now, when people are presented with all the modalities, the visual modality, the audio modality, and the text, we usually prefer just texting to each other or sending voice messages. We don't use that way of communication right now. And, well, what are the limitations? So what are the reasons why we're not doing that? So, of course, the video feed that you see on the screen, it is limited. So it has a fixed viewpoint. You can only see a part of the person you're talking to. It does not convey some of the meaning that we can convey with our gestures. And, well, it also, so this is why we usually prefer actually meeting each other and talking in real life, because the amount of information we can convey is much more than the one that is presented on the screen. And the last problem is why people usually don't take video calls, is that they want to conceal their surroundings, their background. So there is, in a sense, no privacy in these video calls. If you want to take, if your employee calls you and you are still in the bed, usually you won't join the Skype conversation with the video call. You just send the audio. And we believe that the new disruption that will come in this telepresence area will be, in a way, will be a new way to actually communicate. And this is why we are working on these sort of problems. So AR is coming, augmented reality. Virtual reality is also, well, almost there. So these devices will be available, I believe, for everyone. So, and many companies are thinking about the new ways we could communicate using these devices. So Facebook invented these Facebook Spaces avatars. These avatars are, well, programmed to represent your motions and emotions and project them onto that, cartoonish representation of yourself. Well, this avatar is supposed to look like you, but it is still not realistic. It is still cartoonish, and sometimes there is a huge bias in how it represents you. So if you try to run this application, or if you try to run AR emoji, for example, you will get a person that is not you. So you will not recognize yourself in these avatars. And what we think will actually change the world are realistic avatars, ability to represent yourself realistically. And, well, essentially talk to each other, putting on AR glasses, like holograms in Star Wars. Imagine that conference when you are all holograms and I'm just seeing you in my AR glasses. Imagine all the disruption that could bring to our world. Imagine all the commute, all the travel it could reduce. And this is what motivates us to actually work on these problems. And well, this problem is actually quite hard, and it's hard to address with current state of technology. So you can divide this system, this realistic avatar system, into two components. First component is performance capture, when you try to, well, measure what this person that is speaking doing, essentially, capture the motion, capture the movements. And the second part is the creation and rendering of the avatar. Well, what are the requirements and difficulties for the first part? First of all, the setup has to be simple. We can't use the, well, there is established special effects industry that is working well for Hollywood movies when they generate these realistic virtual characters driven by the actors. But the systems are very bulky, so you can see them depicted in these images. But still, we want this representation to be as complete as possible, and also work in real time, of course, because we don't want to have a huge lag and latency in our communications. We do have that already. So it rules out this Hollywood-style special effects devices used for special effects. But the area, this is the problem, but the area I'm working on is actually the way we create these avatars. And what are the requirements here? Of course, the creation process has to be simple. We can't expect people to go to photogrammetric lab and take a full scan of their body in order to create the avatar. We have to rely on one camera feed or multiple videos, well, maybe from different view angles. The representation of you has to be realistic, of course, and it has to run real time, preferably on mobile devices. So these are the challenges. And what are the, well, of course, it rules out some of the existing approaches. And what are the approaches that are being taken right now to solve this problem? So there is a bunch of groundbreaking works, I would say, that try to model this avatar in a completely new way. So I'm going to remove that animation for a while. How would you create an avatar? Probably you would try to do 3D modeling. So you would try to create a 3D model of a person, texture it, and just render from different viewpoints, trying to also project the movements onto that model. But, well, people actually devised a completely new way of making these avatars, and it is using convolutional neural networks and deep learning. So what we can do with deep learning is to take some sort of representation of the human pose, for example, the dense one like here, which encodes the motion and the position of the camera. It tries to directly transform it into an RGB frame that you're going to show to the user in his video conferencing app. And there was a bunch of works in 2018 that tried to do exactly that. For example, Everybody Dance Now, where they tried to make authors of this paper dance. There were even more works that tried to use representations of the pose that are not explicit, so which are also generated implicitly by the deep neural network. But there were some precursors to these works. For example, the Synthesizing Obama work in 2017, which tried to generate the lips movements and blend them onto some other video for some audio. The video portraits, which may consider be a face swap technology. So Facebook also does realistic avatars. And, well, there are some more papers. The point I'm trying to also make here is that a lot of people, a lot of big companies are interested in these technologies and are making developments. Facebook, NVIDIA, Adobe, everyone is interested. Because, well, there is a huge market that they could capitalize on and utilize, and they believe that people are interested in these sorts of applications. But what we were trying to do, all these papers, they require a lot of data, and this is certainly a bottleneck, because if you want 1,000 frames of a person to generate an avatar, that's unfeasible. What we are trying to do, we're trying to reduce the amount of data required to create these avatars. So, for example, if you have 8 frames of that person, and you have another video of the same person, could you retexture that video in a way that is depicted in these training frames? So what we do, we first of all anonymize this video footage of a person, and then we just retexture it. And this is the result of our method. So you can see already where this privacy-preserving conferencing theme comes up. So also, this model is, well, it works only on a person that you train this avatar on. You can use a different face landmarks footage of a different person, but if the geometry of the face is wrong, it will not generate realistic results, as we're going to see later in the presentation. But also, we want this model to be able not only to retexture, but to extrapolate in some sense. What if we have the training data that is only the front of the face, and we want to generate a sequence where a user actually turns his head? So, well, we can do that because we try to make the neural network, deep neural network, understand what the human is. So there is a prior on what the human actually is, and it is able to seamlessly extrapolate onto new viewpoints. So our approach that we take consists of 3 stages. So the first stage is the so-called meta-learning. Meta-learning in deep learning is a hot topic right now, because previously what we did, we took a lot of data and tried to solve a particular problem. For example, classification. So we took 1 million images and tried to classify them into 1,000 classes. But this is not how humans learn. Humans can take 1 image of an elephant, or maybe 2 images of elephant, to understand what elephant is. And there is a trend in deep learning, the ongoing trend, to teach the systems to solve these problems. In a sense, this problem is a transposed one. So we don't have 1 million examples and 10,000 classes. We have 10,000 examples, but 1 million classes. Well, 10,000 examples per class, let's say. So this is exactly what we're doing. We have a limited set of examples of a person, and we ask the model to generate a realistic image given the new pose, a new viewpoint. And we iterate this training process over the large data set of videos. We have more than 100,000 videos of different people for training. But after that, we have to perform the stage 2, and I'm going to show you on the next slide why. For the creation of the avatar of a person, we have to take this new set of images and perform fine-tuning. So we tune that model on a particular set, on a particular task, to solve it better. And after that, we can just use this model, these parameters that we obtained, to perform rendering in real time. So this is how the results look after we perform meta-learning. In the left column, you see the ground truth image that we try to match. And on the right, you see the results for 1, 8, and 32 training frames. So we can actually, after we perform fine-tuning, this is how the picture changes. So it still stays realistic. It still is able to extrapolate to that new pose that we present the picture in. But the identity match becomes much better. But of course, this identity match, the fact that you can recognize actually these people, comes from the reason that we actually use these people's body pose. So exactly the pose that they were in, we just retexture them. And this is one more example about the way that we actually extrapolate. So even given 1 training frame, we can generate a whole sequence. But we can improve with the more training frames, giving the avatar more realism and better identity preservation. Next slide is kind of a fun one. So we've taken videos of these people from YouTube and tried to recreate them, essentially. Well, take some images for training and some for testing. Well, you can see that you can, if you don't know these people, you can probably think that these images are real, but if you know, you kind of see the identity difference. So then they do not look alike. So there is, well, if you consider the application of telepresence, this technology, well, has a lot to go through before it actually is ready for production. And now for the applications. So I mentioned privacy preserving video calls. How would it look like on practice? So here are my selfies that I've taken, 16 of them. I use them to train the model of the avatar and take a novel video sequence of me doing some movements in a different background with a different lighting conditions. Then I anonymize this sequence, so I transform it only to the key points that encode only the expression, but not the background and the texture, and then recreate that. And I can send that over the video chat, so that the person I'm talking to would see only this image. So imagine that you could actually take the calls when you're completely not ready. Or you can even try to synthesize these landmarks from your voice. So a person can choose whether he wants to see your avatar speaking for you or just use a voice chat. So there is one more example of the use of this technology. And of course, now we focused on faces, but you can try expanding that technology to the full body synthesis to actually do a full telepresence system. And now to the more controversial, I may say, application, which we call living portraits. So we can try driving the portraits of people driving with different set of landmarks of a different person. So this is what we get. These are the results. You can see that, of course, each of these videos, because we used different people to generate them, has its own identity, which is transferred onto the avatar. And well, Marilyn Monroe doesn't have her famous mole, so our system is far from being perfect. But imagine the applications of that system for special effects industry. Imagine coming to a museum and having Salvador Dali himself explaining his paintings to you. Imagine Dostoevsky reading his novel from your cell phone when you listen to the audiobook. Or Einstein explaining you general relativity, or, well, maybe special relativity. That's what they do in schools. Well, of course, this is already possible with the current generation of special effects. So you give a special effects artist, a good one, a task to do these animations, and he probably will do it. So it's quite easy to blend one image into another. And what people are actually upset about, I think, is that it's just easier. It takes no time to learn. So you don't have to learn special effects tools. You don't have to learn video editing tools to create these images. And well, yeah, you can see that Mona Lisa is completely different from the painting. But some people actually love the middle one more. So I was talking about the democratization. So let me just go straight to the conclusion. So definitely, these new technologies are about to change the world. And there is like no doubt that this will happen because so many different, these technologies are based on the so-called generative adversarial networks, which appeared in 2014, and they allowed us to generate such realistic synthetic media. And progress in that field, in the field of generative adversarial networks, is easily transferable to any area that you can pick, because it's actually the ability to generate data for your system to train on. You can do self-driving cars with that, generate a sequence during day, and then try to generate a training sequence during night. I myself tried to apply that to Large Hadron Collider and the generation of data for the evaluation of their experiments. So the applications are vast, but there is no way to not transfer that to the generation of synthetic images, synthetic media. So every improvement that we do in generative adversarial network field will be transferred to this synthetic media field. And of course, the topic I mentioned, the telepresence or virtual communications, it will also change the world because, as I said earlier, it will imagine me living 1,000 miles away from my parents. And in order to meet them in person, in order to see them, I have to do this long commute. I have to spend time, I have to spend money. And there are a lot of people in the world that are not able to do that, because they don't have the resources. Imagine them being able to actually communicate like we do in real life over the virtual world, over the internet. So this definitely will be disruptive. And maybe this is the application that we all have to consider in our heads when we think about the consequences of development of synthetic media tools. Special effects industry will be democratized as well. And by democratized, I mean more accessible. When we published this paper, most of the people that approached me were museums, documentalists that were trying to make their films, but they don't have a budget to actually hire special effects crew to do special effects for them. Because, well, of course, you can do all of that, as I said before, already. You just have to have the money to do that. And the technologies like this, they allow people with less money to actually do amazing projects for education, for whatever. And I'm not going to like sweep under the carpet all the problems related to these technologies for generation of synthetic media. I realized that these are the challenges that we faced before. When cameras appeared, portable cameras, it was a huge threat for personal, how do you say it? It's a threat for personal life. So your personal life could be exposed on the camera by taking unauthorized footage. But we as society managed to overcome this. We came with legislation that banned that. We came with punishment that people can actually pay. And here, I think the problem with this that people usually see with these deepfakes, etc., is a problem closely related to another form of democratization of the media. So before we had this social networks, before they appeared, the ability to distribute information between the large groups of people was limited. But when social networks appeared, fake news appeared. So I consider this problem, the problem of tools for generating synthetic media, closely related to the problem of this fake news. And if the latter is solved, so is this one. So I urge you to think about all the good this technology may bring. Think that similar challenges we faced in the past already, if we managed to overcome them, and maybe help us to develop the solution to actually ban the malicious use of these applications and encourage the good use. Thank you for your attention.